Okay, this target is about proving parallelograms, which means we're going to use the properties that we already learned about parallelograms, and we're going to use them to prove that we have parallelograms. So note that all of these statements start with a property and end with, therefore, we have a parallelogram. So remember back in the logic unit, we said hypothesis implies conclusion really means if the hypothesis happens, then the conclusion happens. And so that is what this is saying. If both pairs of opposite sides are parallel, so let's remember that this means parallel, then we have a parallelogram. So we already learned that when we have a parallelogram, we know both pairs of opposite sides have to be parallel. Now we're just saying, what if I have a figure where I know that the one pair of opposite sides is parallel and also the other pair of opposite sides is parallel? Well, then it must be a parallelogram. So I know you don't have necessarily these drawn in, but you could draw them in with us as we go along the video. So I'm just going through and looking at each of those 5 properties that we already learned. And the next one is both pairs of opposite sides are congruent. So remember that that symbol means congruent. Okay, so to mark these congruent, I will mark the congruent markings for one pair of opposite sides and then also for the other one. Okay, the third property says both pairs of opposite angles are congruent. So that I'm going to mark the angles. Remember, this pair is marked in one way and this other pair is marked a different way, like maybe a double arc instead of a single arc. Okay, the fourth property is that consecutive angles, and remember that consecutive means angles that are next to each other, are supplementary. I'm not going to write out the whole word, but that is for supplementary. It's fine for you to write sup. And remember, supplementary means add to 180 degrees. So we can put some angle measures in here. Like, for example, if this angle is 50 degrees, then I can say, okay, well, then the angles next to it, so this angle and this angle, are both 130 degrees because they have to add up to 180. Sorry, that was a little bit small. And then finally, for this last one, we have that diagonals bisect each other. And we can remember that bisect means to cut into 2 congruent parts. So to mark that on the picture, we'll say, well, these 2 halves of the diagonal are the same, and these 2 halves of this diagonal are the same. So all of those properties we already wrote and put into pictures earlier in the packet. But now we have a new one that is a new way to prove parallelograms. So all we did for these first 5 is we just used the properties we know, and we said, well, if we know these, then we will have a parallelogram. And this new one is if we know that one pair of opposite sides are both congruent and parallel, then we have a parallelogram. So one pair means that it's the same pair that this is happening to. So for example, I could choose MH and AT. And I can say segment MH and segment AT are congruent. And then also I will choose the same segments again. Segment MH and segment AT are parallel. So that's supposed to change to blue. Sorry about that. So I'm going to use the blue to show you the parallel. I'll mark that on there. And then we'll go to red to mark congruent with tick marks. But we're marking the same sides. So what happens if we don't choose the same sides? So I'm going to go to a new page and then I'll come back to this. If we don't choose the same sides to be parallel, like we can say, oh, I have a parallelogram. I don't know, my computer is catching up here. I have a parallelogram, and if I say that just this one pair of opposite sides is parallel, if I don't say anything else about that same pair of opposite sides or about the other pair, I might have something that looks like a trapezoid, because trapezoids also have one pair of opposite sides parallel. So that's why our properties say you need both pairs of opposite sides parallel, or these two have to be the same size, because parallel does not mean congruent. They're not the same thing. Parallel just means same slope. Congruent means same length. So again, parallel is same slope. Congruent is same length. They're very different. Please do not mix those up. Okay, going back to page 11. So now, or whatever page it is for you, now we're going to use these six properties here to try to prove whether these pictures are parallelograms or not. So for this one, we can say yes. And the reason that I know that these are parallelograms is because I have it marked so that both pairs of opposite sides are congruent. And I know that that implies that I have a parallelogram.
Kayla Winfield, please come to the main, the front office.
Sorry.
Michaela Winfield, please go to the main doors. Your ride is here. Michaela Winfield.
Oh my goodness. So then this one shows that diagonals bisect each other. And so the things that you're writing here need to be the reasons that we stated on the top half of the paper. So then we have a parallelogram, and this is the short way to write parallelogram. This one is our new reason. This is a yes, because we have one pair of opposite sides that is both parallel and congruent. Congruent and parallel, parallel and congruent. Just has to be both things. So that's a parallelogram. This one, 4, looks really similar to 3. We do have a pair of opposite sides congruent, but then we have a different pair of opposite sides parallel. So this one is a no, because it could look like, let's see, we have a parallel and a parallel and a congruent and a congruent. So it could look like that, which is actually not a parallelogram. It's an isosceles trapezoid. Okay, and then the last one on this page is yes, because forgot to box this one. Because we have consecutive angles, supplementary implies parallelogram. Oh my goodness. Because these guys add up to 180 and these guys add up to 180 degrees. So look out for another video on how to prove parallelograms on a coordinate plane.